All right, so your first problem will look something like this, and you just kind of want to recall that this is going to be a chain rule. A good way to think about this problem is like this instead. What we're doing is this is how they usually write a fifth power, but it kind of helps you a little bit to think of it like this when we're doing our chain rule. So we have an outside function and an inside function, and the outside function is this fifth power here. So how do we do a derivative of a fifth power? Well, we multiply the power to the front, and we take 1 off of the power, and we leave the inside as is. Then we're also going to multiply it by the derivative of the inside, which is secant squared x. And so you are going to have a problem similar to this. You just do the derivative of the outside multiplied by the derivative of the inside. Let's take a look at number 2. This one's pretty similar. Just finding a derivative again. So I'm going to start by rewriting it as secant of 8x squared. And since that little square there is present, that means that we're squaring the whole function of secant there. So I'm going to put it out there like that. So we have an egg, white, and yolk situation. So here's the shell. Here's the yolk. And everything else left in black there is the egg whites. So if I were to do the derivative of the shell first, that would be a power rule. Just move the 2 to the front and take 1 off the power, like so. And then if I were to do the derivative of the egg whites, that's the secant part here. The derivative of secant is secant tangent. And we keep the inside the same for that. And then finally we have the derivative of the yolk part, which is the 8x squared, which is 16x. Okay, and how would they put this together? Well, there's a few ways you could put this thing together, like 2 and 16x. You could put those together to make 32x. Also, since this secant is a first power and we have another secant here, we can actually put those together as a secant squared. And then we can just tack the tangent on at the end. I don't know how much you'll be able to simplify yours, but there's our derivative. All right. So let's go ahead and move on to number 3. All right, so we want to find the derivative of this expression here. So I've got ln of x is equal to arc cosine of y. Now this is a implicit function. So when you want to find the derivative of an implicit function, you take the derivative like you normally would. So the derivative of ln is 1 over the inside. And then the derivative of arc cosine is going to be negative 1 over the square root of 1 minus y squared. Now, when you're doing implicit differentiation, remember when this and this letter don't match, you have to put a y prime there, okay? Which is just another way of saying dy dx, right? So I want to get the y prime by itself now. So I'm going to multiply both sides by the square root of 1 minus y squared. And since I do that, those are going to cancel. And whatever you do to one side, you do to the other, right? And then we also, I guess I'll go ahead and write what I have, just so we don't have too much mess to look at here. Multiplying that by the 1 on the top, it just stays the same, right? So that's what we're left with. The last thing we do is take that -1 off here and move it over here, right? Just by multiplying both sides by a negative, or you can think of it as dividing. But in any event, that's our final answer there. Y prime, which is another way of saying dy dx, is this. So what I did was I took the derivative, and you got to remember, if you take the derivative of something with a y in it, you put a y prime next to it, and then you get that y prime by itself. Let's go ahead and take a look at number 4. So we want to find the derivative of this guy here. That's an exponential function. And when you take the derivative of an exponential function, you always just get the same thing all over again. But since it's not a base e, we do have to multiply it by an ln of 3 also. So whenever you have an exponential function, you get this all over again, multiplied by ln of whatever your base is, in this case 3. So that's the end of that one. Pretty straightforward. Let's go ahead and take a look at another one. All right, number 5, we have f of x is equal to this function, and we want to find ln of f prime of 1. So basically, I would want to find f prime of 1 first. So let's do that. Here's f prime, and here's f prime of 1. Just plug in 1, right? And I end up with 1. So I want ln of f prime of 1, and I just found out f prime of 1 is 1, and ln of 1 equals 0. Now something else that will come in handy for you guys to know about here is this. If you have ln of e, that equals 1. And another thing, particularly on the problem you guys are going to be working on, is this, ln of e squared. Well, that's just going to be 2. Anytime you have ln of e and then there's some power here, the answer will always be just that power value, just so you know. That'll come in handy on this problem. That's an old pre-calculus rule for logarithms. So let's go ahead and move on to number 6. This one's a lot like number 4, but it just has some additional stuff on it. So here we go. The 5, if we take the derivative, is just going to stay because it's a constant multiple. Also, when you take the derivative of an e function, it stays exactly the same. But we do need to multiply by the derivative of the inside, which is 4. So if we go ahead and put the 5 and 4 together, we get that. So this was a chain rule with a constant multiple rule involved. So the chain rule is e is the outside function and 4x is the inside. So we have our derivative of the outside multiplied by the derivative of the inside. And then we have our constant multiple here, the 5. It just stays there, and we put the 5 and 4 together. All right, let's go ahead and take a look at number 7. So for 7 through 10, this says 6, 7, 8. Let me fix that. So for 7 through 10, I feel like they're pretty straightforward, so I'm not going to be going through any examples with them, but I will just tell you some clues and hints that'll be helpful. For number 7, you want to use your quotient rule. For number 8, it's a chain rule. For number 9, you want to use your unit circle. And if you're having trouble with example number 10, take a look at the video where I went over example 2 a little bit earlier. That'll help out on that one as well. So that being said, I'll let you guys work on it from there, and good luck, and we'll see you guys in class.